Hi everybody, welcome again. This is Oliver. We are finishing up section 1.6 today, a review for mastery and challenge practice problems, about 11 problems for today. The goal in section 1.6 is to represent functions as rules and as tables. So let's start. Number 1, identify the domain and range of the function. So the domain, or D, would be 2, 5, 7, and 8. The range, or R, would be 5, 11, 15, 17. Number 2, the domain would be 1, 3, 4, and 7, and the range would be 2, 8, 11, and 20. Okay, number 3, make a table for the function. Okay, table for the function. So D, or domain, R, or range, we have 0, 3, 5, and 7. The function is 4x, so 4 times 0 is 0, 4 times 3 is 12, 4 times 5 is 20, and then 4 times 7 is 28. So the range is 0, 12, 20, 28. Number 4, table, the domain, and the range. The values are 1, 2, 3, 4. The function is 3x minus 2, so 3 times 1 is 3 minus 2 is 1, 3 times 2 is 6 minus 2 is 4, 3 times 3 is 9 minus 2 is 7, 3 times 4 is 12 minus 2, 10. So the range is 1, 4, 7, and 10. Number 5, write a rule for the function, and the function, okay, so this is y, this is x. Write a rule, so it's gonna be something like that, y equals, right? So let's see, 3, 5, 7, 9, 14, 16, 18, 20, they all increment by 2. So this one just has a different starting point, and that's it. 14 minus 3, 11. So this is basically 11 plus x. So when x is 3, 3 plus 11, 14. When x is 5, 5 plus 11, 16. 7 plus 11, 18, 9 plus 11, 20. So this is the rule for number 5, 11 plus x. Number 6, we have 6, 7, 8, 9 increments by 1, 3, 3.5, 4, 4.5. This increments by half, right? We can see 6 and 3, 7 and 3 half, 8 and 4, 9 and 4 half. So this is basically dividing x by 2. So this is y equals x over 2. 6 divided by 2 is 3, 7 divided by 2 is 3.5, 8 divided by 2 is 4, 9 divided by 2 is 4.5. So y equals x half. That's the rule for the function, for number 6. Next, challenge practice problems. Okay, number 1, make a table for the function y equals 3x squared plus 2. Determine the domain values corresponding to range values of 2, 5, 14, and 29. Okay, so let's see here. Okay, I'm going to do it right here. So we have domain, we have range. The range values are 2, 5, 14, and 29. This is y, right? And y is 3x squared plus 2. Determine the domain values corresponding to these range values. Okay, so y is 2, right? So 2. Okay, so if y equals 2, we have 2 equals 3x squared plus 2. Plus 2 on the other side will be minus 2. 2 minus 2 is 0. So 0 equals 3x squared, or x is 0, right? Because 3 times 0 is 0, so x has to be 0. So here is 0. Then here we have y is 5, so 5 equals 3x squared plus 2 on the other side minus 2. 5 minus 2 is 3, so 3 equals 3x squared. So 3 times which number is 3? 1. So x squared has to be 1, so x is 1. So x is 1. The next one is 14, y is 14, 3x squared plus 2. 14 minus 2 is 12. 3 times x squared. 3 times what number is 12? 4. So x squared is 4, or x is 2. And then 29, right? So y is 29, so 3x squared plus 2. 29 minus 2 is 27, equals 3x squared. Or 3 times which number is 27? 9, so x squared is 9, or x is 3. So make a table for the function. Okay, we did. Determine the domain values. The domain values are 0, 1, 2, and 3. So we're done with 1. Number 2, make a table for the function. Okay. Again, let's do it here this time. Domain range. So this was number 1. This is number 2. Make a table for the function y equals 2x cubed plus 1. Determine the domain values corresponding to range values of 3, 17, 55, and 251. If y is 3, becomes 3 minus 1, 2. Okay, so let's do it here. 3 equals 2x cubed plus 1. So 3 minus 1 is 2. 2 is 2x cubed, or x cubed has to equal 1, right? Because 2 times 1 is 2. So x cubed is 1, or x is 1. Because 1 times 1 times 1 is 1. So, okay. Next one, when y is 17, we get 17 equals 2x cubed plus 1. 17 plus 1 on the other side will be minus 1. So 17 minus 1 is 16. 2 times x cubed. So 2 times 8 is 16. So x cubed is 8. Or x is 2. Because 2 times 2 times 2 is 8. So this is 2. Next one is 55 for y. 2x cubed plus 1. So 55 plus 1 minus 1 on the other side. So this becomes 54 is 2 times x cubed. 2 times 27 is 54. So x cubed is 27, or x is 3, because 3 times 3 times 3 is 27. So it's 3. And then last one is 251. So y equals 251. So 251 equals 2x cubed plus 1. So this is 251 minus 1. So 250 equals 2 times x cubed, or x cubed is 125, because 2 times 125 is 250. So x cubed is 125, or just x is 5, sorry. So x is 5, because 5 times 5 times 5 is 125, because 5 times 5 is 25, and 25 times 5 is 125. So this is 5. So number 2, determine the domain values 1, 2, 3, and 5. Number 3, the function y equals x squared plus 1 has the following table associated with it. Okay, suppose the function is reversed, making y the input and x the output. Okay, so we have xy, but we have these reversed. So, so these values will be x's. So 5, 2, 1, 2, 5, and 10. And then these values will be y's. So we have minus 2, minus 1, 0, 1, 2, and 3. So suppose the function is reversed, making y the input and x the output. You would have to remove some of the values of y from the table in order to have x be a function of y. What would be the minimum number of y values you would have to remove from the table in order to have x be a function of y? Okay, so previously we had y equals x squared plus 1, y equals x squared plus 1. Then what would x be equal to here? So x squared is y minus 1, because plus 1 on the other side will be minus 1. So x squared is y minus 1, or just x equals square root of y minus 1. So this is basically the function, or in our case here, it will be y equals square root of x minus 1. So this is the function that we are representing here. So let's start with 10. So 10 minus 1 is 9, square root of 9 is 3. So yes, this is good. When x is 5, 5 minus 1 is 4, square root of 4 is 2. So yes, this is good. When x is 2, 2 minus 1 is 1, square root of 1 is 1. So yes, this is good. When x is 1, 1 minus 1 is 0, square root of 0 is 0. So yes, this is good. 2 minus 1 is 1, square root of 1 is 1. But we have negative 1. So this is, we will have to remove this value. The value of 2 we will have to remove from this, from the domain. And then 5 minus 1 is 4, square root of 4 is 2, but we have negative 2, so this also we have to remove. So what would be the minimum number of y values you would have to remove? 2. So two values to remove. Okay. Number 4, refer to exercise 3, which is this one. What y values would you have to remove from the table? Those would be basically 5 and 2, the domain values of 5 and 2. Okay, so that's number 4, 5 and 2. And then consider the table for a function. For what value of n would this table represent x as a function of y? Well, any value that's not here, except we can have minus 2. Why? Because we can have the same input have two different outputs, right? That's not a function. You can have one input and two outputs. Function is when you have one input mapping to one output. Okay, so it cannot be minus 2. Also, it cannot be 1. It cannot be 2. It cannot be 3. It can be minus 1, right? Because minus 1 and 4, we have 4 here, 4 here. So minus 1, it can be minus 1, but it cannot be minus 2. So any value except negative 2 right here, 1, 2, and 3. Because if n is minus 2, 1, 2, or 3, you end up with one input and two outputs, right? If it's minus 1, you're going to end up with 3 and 4 as outputs. If it's 1, you're going to end up with 4 and 6 as outputs. If it's 2, you're going to end up with 4 and 5 as outputs. If it's 3, you're going to end up with 4 and 10 as outputs, and that's not a function. So n cannot be these 4 values. Any other value is okay. So that's all for today. If you'd like to see more videos, please like and subscribe to the channel. Thank you so much, guys. See you next time. Bye-bye.